So yeah, hi. My name is Cristian Serb. I'm working in Berlin, and I'm mainly working currently around blockchain technologies. Um, um, I took the last 2 months, or approximately 2 months, to experiment with blockchains, and what was like the main interesting part for me was how can you build like a very simple blockchain, and how can you also demystify blockchain engineering, because currently everything around blockchain is very blown up, and everything sounds very complicated, and um, um, it's actually also hard to understand, without a doubt. But you can make an effort into building something and creating something that it's more accessible, and that is for everyone easier to read. So this was my goal, this was my motivation, and I did it just because I wanted to be honest. Um, yeah, so full disclosure also, this is what I'm going to present is definitely early alpha stage, and it's also still currently an experiment. So just a quick introduction about me. My name I told you already. I was lucky enough to be like from the very beginning in Berlin when Ethereum started. They have their headquarters there, actually, like, or developing headquarters. Solidity is developed over there, and they created obviously also a meetup, and I created the second one in cooperation with them back when they started. And apart from that, I was working also in blockchain and cryptocurrencies research at Solaris Bank. Solaris Bank is startup bank in Berlin, and they wanted to find out how they can use blockchain and cryptocurrencies in their business. As it turned out, they can't really very well, but they started offering financial products around like cryptocurrencies, mainly bank accounts for exchanges and so on. And now I'm a CTO at Amatus, and Amatus is a company builder, which is also centered around blockchain, but not exclusively. Anyhow, so this is kind of obvious, but there's like no one blockchain, right? I don't even know if this translates to correct English, but I hope you get what I'm trying to say. So it's complex software, right? And it requires you that you make compromises, and you kind of have to decide how you store your data, and depending on how you store your data, you have to make different compromises. One of those is also like proof of work, right? Or proof of stake, or proof of authority, or proof of time elapsed, or proof of whatever you want. I think there are like 20 by now. So what are we going to look at today? So let's like the piece of software that I built is inspired around Bitcoin, and it's going to use the P2P gossip protocol, like a very simple one. I will explain it in a couple of minutes. We are going to use proof of work, and I'm going to talk a little bit about also consensus, like briefly at the end. All right, so let's have a look at the data, right? So how do you store data? So on the left, you see Bitcoin, which this is just a Bitcoin header of a block, which is then again for Bitcoin wrapped around more data. The transactions, for example, are in the above layer. and I think the size of the block is in there, and other things. So, and on the right side, I have like an example what I'm going to use, like in a simplified blockchain, like just the previous block header hash, because we just need it in order to create a blockchain, and then the time and the nonce. I will say something about the nonce in a bit. So, and this is how it looks like. It's just simple JSON. I just use good old JSON because that's simple. So you have the hash of the current block, the parent hash, the timestamp, the nonce, and then the transactions in an array. That's it. And then for the proof of work, there are some concepts that you kind of have to, you kind of have to remember, and they're all important, even in a like a minimum viable blockchain. So the way it works, and I will show it in an example, is that you're trying to find a hash that is numerically less than the target threshold, and the target is calculated based on the difficulty, and the difficulty is calculated based on the time it took to mine the last 2016 blocks. Bitcoin has like hard-coded calculation for the difficulty, and every 2016 blocks it's calculating the new difficulty. And if it took too long to mine a block, for example, or too long or longer than anticipated, then the difficulty is going to be lowered. And if it took less because, I don't know, China opened a new mining pool, then the difficulty is going to be increased. So let's have a quick look at how proof of work, like in my example, works. So let me open up the console. Actually, I'm going to show something also. So the way it works, like, is with every hash, you give some data as input, and then brings out a hash. But you're trying to find out something that is numerically lower than the target threshold. So let's try this. So let's try to find proof of work for the data for the string blockchain, right? And let's set the difficulty to let's say 3. Let's say this was pretty fast. There is no it's smaller, but it doesn't even show a 0 at the beginning. So let's try to put it maybe like to 10. Yeah, there you go. So it has like already 2 zeros at the beginning, and you can see the nonce over here. So 407, which basically means it tried 407 times to find the correct hash. Now let's raise it maybe to 20. I think this is going to be already longer. Yeah. So this is probably even a bit longer than we want to wait. I don't know, probably around like 2 minutes. So maybe let's choose something else, which is like Coding Serbia. And this was faster, right? So you can see that it's also dependent on the obviously on the input data that you're giving it. It tried 45,000 times, and then it found the hash that is smaller than the target threshold. Yeah, Bitcoin aims to have it to have a block mined every 10 minutes. Obviously, because of the different inputs, it varies, right? But it's always in the minutes, right? The time span. Yeah, and the P2P protocol that I used, which I wrote, from scratch also, even though it's extremely simple and it takes very little actually to surprisingly little to write a P2P protocol. It's the first time that I did it, and it works for my example quite well. It's simple gossip. So the way gossip works is that it just broadcasts to the connected nodes that to the surrounding nodes, basically. That's it. I will show also an example about this. And what is also needed is you need to find other nodes, right? So if a node starts up and it tries to connect to the network, it just needs to find other nodes. So the way to do this is Bitcoin has networking network routers that or this functionality. You can turn it on and off, I think, for Bitcoin. And it basically tells you about other nodes in the network, and then you're just connecting. You're making a handshake to those one of those nodes, and then you're establishing a connection. I did everything with HTTP, over REST protocol. So like the handshake, everything, the transactions, and the blocks are being transmitted via REST, and like post requests or so. Just to add to the last slide, it's broadcasting everything, and the way it decides to do the broadcasting is it just broadcasts everything that is new. That's it. That's the whole logic, and it works quite well. So let me also show here something. So I wrote some helper tools that is basically just starting up some nodes for me, starting up the routing node, and also can start up miners, and it's just a helper tool, right? So I will just start it here, and then hopefully you're going to see it there. So this is an explorer that I built, and unfortunately, due to the effect of presentation, it doesn't work. Anyhow, it's an explorer that I wrote. Every node has also like a WebSocket open that I'm then connecting to, and then the node can communicate with this this interface and tell it like I'm now connected to 3004 is now connected to 3005, and so on. Let me restart this maybe, and then maybe it looks better. Give me 1 sec because this is kind of important. Sorry about that. It used to work like 10 minutes ago. So yeah, this is extremely simple logic behind this, right? This one, and that's also what I wanted to achieve, like having like extremely simple logic to just create like a very simple network. They are basically just connecting to each other, making a handshake, and then telling via WebSockets I am connected. That's it. And then I will show also broadcasting, which works perfectly fine just by this this logic. We can also start way more. Yeah, and it performs quite well. Yeah, I was talking a little bit already about node roles. So Bitcoin is also mainly kind of this roles, like a full blockchain role, with basically a node that downloads the full blockchain and then also can validate historically all transactions without asking any other external sources. Then there's obviously the miner, and you can turn it off and on. It's also, and then the networking routing node. All of those roles are also being covered in what I've wrote here, just because you need it. You need it in order to have a functioning network. Okay, so yeah, that's the next slide. So why is it important to reach probabilistic finality before the next block proposal? So the reason is that if you take a look like at this, let's move the mouse over there. So assuming we have like blocks being mined, and then another block is being mined on top of this one, which is basically saying putting this block as the parent hash, and so on and so on. You have like the well-known chain structure, and then once in a while it happens, obviously, that two blocks are being proposed at the same time. Just because it happens, because two miners are finding are finishing the proof of work at the same time and are proposing it, and then it takes around 12 seconds for anything, a transaction or a block that you are propagating on the Bitcoin network to reach all the nodes in the network. Yeah, those are the 12 seconds. And then let's say the same miner that mined this orange block then starts mining directly the next one, and it mines it on top of the orange one, because he obviously wants his own block to succeed and be part of the longest chain. But then it takes him way longer than the one who mines the blue block, and the blue block, he receives notice about the blue block even before he finishes his own block. So at the time he abandons it, and obviously the chain continues here. But if you think back again, so it takes 12 seconds for, let's just talk about blocks, for each block to be propagated to all the nodes. Then if for whatever reason mining takes 2 seconds, then then miners are constantly going to propose new blocks. And since also in Bitcoin, the way you decide which one of the blocks you're actually going to accept it as the as a not necessarily as a valid block, because they can all be valid blocks, but as the block that you want to build on top on again, or be part of the longest chain. Yeah. So so if you all the time get new blocks, then a fork persists, right? Because if I'm here, no, I'm not here. If I'm at this current step, let's call it like a step. If I'm at this current step and I'm a node, I'm not even a miner, but I'm a node that is going to receive two different blocks proposed at the same time. They all have basically the same length or the same work behind it. How am I going to decide which one to choose? So and this could go on potentially forever, but because it takes such a long time to mine a block, which is intentional, this problem is usually also resolved. It's usually resolved within like one step, sometimes maybe 2 steps in the Bitcoin network. Yeah. So before I'm going to show a little bit more about like the visuals that I just showed also. What is missing in order to create like a very simple blockchain from also like in comparison to what I've talked about up until now. So from a high level, apart from the details, there are obviously a lot of details missing. But apart from the high level, apart from details, sorry, from the high level perspective, there are two things missing, which is signing transactions and a better P2P protocol. So if I would want to roll out a testnet, it's going to be very hard because P2P in general is kind of hard also. So this works very well in on my local machine, but it's going to end pretty bad in if I would want to roll out like a testnet. For example, there's, I don't know, like TCP hole punching missing. There are different, or there's more logic missing for establishing a position like within the network, connecting itself well to other nodes, making sure that they are connected well to other nodes, not just ending up like having one connection and yeah, those kind of things. So now let me show what I ended up with. So what we see here is I just wrote like again a helper script to start up all the nodes, create transactions, which are mouse again here, right? So they're being created as we speak, and then to mine blocks. And now every time a block is mined, it changes basically to the newest block, accepting it as the final one. This one is just a bug in the Explorer. Sorry about that. But here you can see that it basically continues to put out new blocks. Sorry. So here are the blocks at the bottom, and yeah, those are the miners. The miners are marked with red, and every time they receive I think 2 transactions or something like this, they are putting it into a block, and then they're proposing a block. That's it. Those are all full nodes. They're all connected to each other via REST, or like it's kind of like a loose connection, right? So just making a handshake, and that's it, right? Any questions so far? No questions. Great. Then unfortunately my talk is also over sooner than anticipated. So thank you for coming. You can take a look at the project at github.com and then Cocol project, or just follow me or hit me up on Twitter. Thank you.